Hello students, this is Dr. Shell here. This is a video lecture to give you an introduction to our Module 4, which deals with categorical logic. We're going to start with understanding what a categorical statement is. That requires understanding how to use and understand Venn diagrams. That will lead us to categorical arguments, and then you'll understand how powerful this tool is in evaluating arguments. It is a intense unit. There are several videos to watch and some reading to do to make sure you really understand it. This unit has a unit exam. There's no written assignment for this unit. It really requires that you really master and understand how categorical logic works. Then you'll use this categorical logic in later assignments to evaluate arguments. You may recall that I give the analogy that logic is like building a house. And you have the material that you use and you have the blueprint that is guiding the construction. Logic requires that you have both good diagram and good materials. But before we can evaluate the material, or before we go into the process of evaluating the material, that is, deciding whether or not particular statements are true or false, so we know how strong or cogent our argument is, we want to first look at the blueprint. Because if the blueprint's bad, then it really doesn't matter whether the materials are good or not good, because it's a bad idea before you even start. The construction, that's why we call it formal logic. The form is bad, so there's no need to go any further and examine the content of the materials. So categorical logic in particular is a way of analyzing the construction of the argument to decide if it's even worth pursuing any further. So let's take this argument, for example. All logic students are smart. Some smart students get A's. Some A's will go to logic students. Now, this is a categorical argument, or sometimes it's called a syllogism. And as you watch the videos and read the material, you'll understand why. But it's made up of 3 statements. They have to take a certain form, either all, no, some, or some are not. And then the idea is that if the first two statements are valid, then they will lead to the conclusion. Okay? Now, when you take these 3 combinations together, there are actually 256 possible combinations, but only 24 of them are valid. So this is where the power of categorical logic comes into play. What we know from categorical logic is this argument has a name. It's an AI4, and it is invalid. It's always invalid. In other words, going back to the architecture, going back to the blueprint is wrong. So I don't even need to stop and think about whether or not these individual statements are true or false, because the argument is flawed. And an invalid argument can never lead you to a conclusion in which you can give absolute certainty. So this argument is invalid, dead in the water. It is not one of the 24 valid arguments. So you may have sensed that something wasn't quite right. So think about this using our Venn diagrams. There is a group that includes logic students. There's a group that includes smart students. And there's a group that includes students who get A's. And this argument is saying that there is a relationship between those 3. That's essentially what an argument is. I'm giving you 2 statements, and I'm saying that those 2 statements entail or will lead you to my conclusion in the relationship between these 3 categories. Okay, so when we draw out the logic implied by that statement, it looks like this. Now, you don't know the rules of making these Venn diagrams, but let me just walk you through this. So the blue shading is empty space. So all the logic students have been shoved into the overlap between logic students and smart students. So all logic students are smart, but there are other smart students who are not logic students. So they're outside the logic student Venn circle, but all the logic students are inside the circle of smart students. Now, there is an X on the line between logic students, smart students, and students that get A's. And the reason it's on the line is we know there are some smart students who get A's, but we don't know if they are logic students or not. By the argument, we're not sure which way that X is falling. There are some smart students who get A's, but the logic of that statement doesn't prove to us that logic students are in that group, and therefore it's invalid. It actually has what's called an undistributed middle term, and you'll learn all about that when you watch the lectures. So in addition to the readings that are linked in the course overview and resources, there's a series of lectures to watch in this section. There's Becoming a Venn Master with Dr. Shell. So first you have to master the art of the Venn diagram. That will lead you then to be able to understand Aristotle's square of opposition. So you'll understand where these four different diagrams, statements are coming from, and then how they are connected into an argument. So once you understand that there are these four basic statements, and then they can be combined in a categorical argument, and you'll discover that there, as you can see, there are literally 256 kinds of ways you can construct those arguments, but only 24 are valid. So once you work your way through the lecture on categorical pizza, you will understand how to sort out the valid and invalid. So rather than learning all 256 arguments, you learn 4 rules, and those rules will allow you to know when you are confronted with an argument whether it is one of the 24 valid arguments or not. So that's the task of this unit, is to master categorical logic, and then be prepared to take the exam and be able to use categorical arguments and recognize them when they are in play.